how are you? We are going to study atomic structure. Okay, physics lesson 11, atomic structure. Okay, atomic structure. Sorry, chemistry. Unit 11, atomic structure. Already we studied Unit 10. Yes, Unit 10 already studied. Yes, now we will study atomic structure. Already we know what is atom. Atom, you know? What is atom, you know? Yes, the atom have proton, neutron, electrons. Already we studied in the lower classes. Yes, children. Discovery of atom. Atoms, see the picture everybody. See the picture. Neutrons, protons, that two together make a nucleus. The outer electrons are there. Electrons are there. Everybody see the picture. Yes, it is a atom. It is a atom. Proton, neutron is inside. Electron is outside of the nucleus. Okay, it is the structure of atom. Now, discovery of nucleus. Yes, the inside of the proton, neutron is there. That is a nucleus. Yes, who discovered in 1911? Rutherford, Lord Rutherford, a scientist from New Zealand. Scientist from New Zealand, Rutherford, performed his famous experiment for bombarding in thin cold foil with very small positively charged particles. Very small, thin, positively charged particles called alpha. Small, positively charged particles called alpha. The alpha particles, that is the positive charged particles. He selected a gold foil because he wanted as thin layer as possible, and gold is the most malleable metal. It is a metal. It is a malleable metal. Okay. So everybody see here Rutherford alpha scattering experiment were the first experiment in which individual particles were systematically started and detected. This is known the standard operating procedure of particle physics. Yes, this one we will see properly. Alpha particles by the gold leaf. See the picture everybody. Experiment given here. Beam of particles coming from the sources of particles. The gold foil is in between. In the circular fluorescent screen is there. Everybody see the picture. Circular fluorescent screen. In between the gold foil is there. Gold foil. The sources of particles, the beam particles coming from the sources of particles. That one going to the gold foil. Gold foil. Gold foil. That someone reflecting, someone scattering, some little scattering, someone more scattering, someone deflected. See the picture, everybody see the picture. A very small number of alpha particles are significantly deflected. Very small number of alpha particles. deflected. Yes, that someone deflected. அது தொட்ட உடனே பின்னால போயிட்டா அதான் deflected. Yes. Next one, see, a few alpha particles are slightly deflected. Slightly deflected. கொஞ்சம் first lineல பாரு, few alpha particles are scattered because of repulsion by tiny positive nucleus. Slightly deflected. Most alpha particles pass straight through foil. Most alpha particles straight, going straight, not deflected. Not deflected. Okay. Luminescent screen to detect the scattered alpha particles. Luminescent, that fluorescent screen, circular fluorescent screen that detect the scattered alpha particles. Scattered. Okay, that right. How? See, everybody saw the picture. Now we will that Rutherford selected a gold foil. Why gold foil only selected? Because he wanted a thin layer as possible, and gold is the most malleable metal, so only selected gold foil selected. Okay, he observed that most of the alpha particles pass straight through the foil. See the picture, the most of the alpha particle going straight. Yes or no? See the picture, straight line, more particles are there. Some alpha particles were slightly deflected from the straight path. Straight pathல இருந்து கொஞ்சம் deflect ஆயிருக்கு. Very few particles completely bounced back. அது அந்த கோல்டு ஃபால்ல தொட்ட உடனே அது பேக் சைடில் வந்துச்சு. completely bounced back. Okay, that deflected alpha particles. Later, Rutherford generalized this result alpha particle scattering experiment and suggested model of the atom. That is known as Rutherford's atomic model. What is Rutherford's atomic model? Rutherford generalized this result of alpha particles scattering experiment and suggested a model of atom that is known as Rutherford atomic models. Have you understood? Alpha particle scattering experiment and the suggested model of the atom that is known as Rutherford's atomic model. Okay. Yes, now we have to see the picture. The center nucleus is there. The outer electron is going there. Electron. Rutherford concluded that atom is mostly empty space. Nucleus only is in center. The all other place the empty space. However, the atom contains a nucleus where the mass and positive charge of the atom are concentrated. Now we know that the nucleus contains proton and neutron. Nucleus contains proton and neutron. Electrons orbit the nucleus but are not part of it. Not a part of it. See the picture? Electron is there, one orbit also there. The orbit is the path of the electron. அந்த எலக்ட்ரான் வந்து சுத்திட்டே இருக்கும், அந்த பாத்து தான் இது electron orbit. Okay. The atom contains large empty space. There is positively charged mass at the center of the atom known as nucleus. The size of nucleus of atom is very small compared to the size of atom. Yes, size of nucleus very small. The electron revolves around the nucleus in closed circular path called orbit. What is orbit? The electron revolves around the nucleus in the closed circular path is called orbit. An atom is whole electrically neutral. the number of proton and electron an atom is are equal. How many number of protons are there? That equal number of electron also there. That is in the same element. Okay? Yes. See the picture. Nucleus is in center. Electron is in the outside. Nucleus is a neutral because that positive charged proton is there and neutron also there. That positively charged proton attract the electron. Okay. Rutherford model atomic is similar to the structure of solar system. See the picture. Solar system like this also revolving around the nucleus. You think nucleus is a sun. Nucleus is like a sun. Yes. One electron revolving around the nucleus. That like every planets also revolve around the sun. Okay. The like a similar like a solar system. Sun is the center and the planets revolve around it. Similarly, is an atom, the nucleus present at the center and the electron revolve around the orbit of the shells. Okay. Yes, it is a Rutherford model of the atom. Okay, children. Rutherford atomic model. Rutherford atomic model. Otherwise, model of atom. Okay. Yes. Have you understood? Very easy. Yes. Next we have Rutherford's model. Limitations of Rutherford's model. According to Rutherford's model, electron rotates with uniform velocity and around the nucleus. Uniform velocity that are around the nucleus. Yes, the Rutherford electromagnetic theory, the moving electron should accelerate and continuously lose energy because it's rotating, lose their energy. Due to the loss of energy, path of electron may reduce and finally electron should fall into the nucleus. Electron என்னதுக்குள்ள போயிருது? Fall into the nucleus குள்ள போகுது. Fall into the nucleus. If it happens, so atom becomes unstable. அப்போ atom என்னதாயிரும்? Unstable ஆயிரும். Stable இல்லாம ஆயிரும். But atoms are stable. ஆனா atom வந்து stable. The Rutherford சொல்றது இப்படி எனர்ஜி எல்லாம் போய் இந்த எலக்ட்ரான் போய் எங்க போய் விழுந்துரும்? நியூக்ளியஸ்ல விழுந்துரும் சொல்லியிருக்கு. அப்போ என்னது? இது ஒரு கரெக்டான மெத்தடு கிடையாது. ஏன்னா ஆட்டம்ஸ் ஆர் ஸ்டேபிள். ருதர்ஃபோர்டு மாடல் படி பார்த்தோம்னா ஆட்டம்ஸ் ஆர் அன்ஸ்டேபிள் வருது. ஸோ ருதர்ஃபோர்ட் model failed to explain the stability of an atom. So Rutherford model is not correct. It is not acceptable because atoms are stable. Here atoms are unstable here. So Rutherford model failed to explain the stability of an atom. Okay children. Force model of an atom. Force model of an atom. Force. One scientist in 1913, Niels Bohr, a Danish physician, explained the causes of stability of atom in a different manner. The main postulates are number one, in atom the electron revolves around the nucleus in stationary circular path called orbits, otherwise shells. Already we studied, yes. Shells we studied. Yes, listen. The orbit electron revolve around the nucleus in the stationary circular path. That is called orbit. See the picture, everybody. Neutron is center. Neutron, that is a Neutron and proton make a nucleus that is in the center. First orbit, that is a K shell, otherwise number one shell, first one shell. Number 2, that is a L shell. Number 3, that is a M shell. Number 4, it is a N shell. That like K, L, M, N. That like 4 numbered. 1, 2, 3, 4 like this. Orbits are there. First orbit. Electrons are moving the first orbit. How many orbits? That we studied after. Okay. Here the atoms revolve around the nucleus. That nucleus revolving around the nucleus, that is orbit. Electron can neither lose nor gain energy. Rutherford said electron lost energy. Here this Bohr force, the force model said that here not gaining energy, not losing the energy. Neither loses nor gain energy. Okay. The electron in shell can move to higher or lower energy shell by absorbing or releasing a fixed amount of energy. A fixed amount. First cell, K cell. K cell have only 2 electrons. That like that a fixed represent that electron shell can move higher or lower energy cell by absorbing or releasing fixed amount of energy. Fixed amount of energy. The orbit closest to the nucleus, that is K shell. That is the first orbit. Next, it has least amount of energy and the electron present is called K electron, and so on the successive cells and their electron. These orbits are associated with fixed amount of energy. So Bohr called them as energy level or energy shells. Energy level or energy shells. What? Next, do you understand these all? First cell K, L, M, N. That like 4 cells are there. That also fixed energy. Fixed energy. So what are the limitation we will see? What is the limitation of force model? Here limitation Bohr model or quantum idea of stationary orbit is mixed with the classical idea of Coulomb force. The assumption of only circular orbit is utterly unjustified. It is not justified. It can only explain the line of hydrogen and nitrogen, hydrogen and hydrogen like atom, not other atoms. Have you understood? It is only hydrogen and hydrogen like atom. Hydrogen like atom means what? Helium, lithium, beryllium. These are hydrogen like atom. These atoms only applicable. These atoms only applicable. All other atoms not applicable. Okay, this model was applicable only hydrogen and hydrogen like atoms. Hydrogen like ions. Sorry, hydrogen like ions. Hydrogen and hydrogen like atoms also, that not explain the all others. It could not be extended to multi-electron nucleus. Could not be extended to multi-electron nucleus. So these are the limitations of force model. Okay, these are the force model limitation. Next one we have of the neutron. Discovery of the neutron. Who discovered a neutron? James Chadwick observed. James Chadwick observed when beryllium was exposed to alpha particles, the particles with about the same as as protons were emitted. Beryllium plus alpha rays that gives rise to carbon plus neutron. Carbon plus neutron. Beryllium plus alpha rays. Beryllium only took. Okay. Beryllium and alpha rays that gives rise to carbon and neutron. These emitted particles carried no electrical charges. Because neutron is there, no electrical charges. They were called as neutrons. Because neutrons only have no charge. It is denoted by N, atomic number 1, atomic number 0, mass number 1. The superscript 1 represents its mass and the subscript 0 represents its electric charge. 1 is the mass, 0 is the electric charge. That is here electric charge 0, that is neutron. Have you understood, children? Properties of neutron. What is the property? These particles was not found to be reflected by a magnetic or electric field, proving that electrically neutral. Because charged means that deflected by the electric or magnet. Yes. So this one have no charge, so it one not deflect by the magnet or the electric field, proving that it is electrically neutral. So its mass is equal to 1.676 multiplied 10 power minus 24 gram. 1 AMU. 1 AMU. So these are the properties of neutron. These are the properties of neutron. Chadwick said experiment discovering neutron. Alpha particles to projected towards the beryllium target. Beryllium target only. The emitted particles fell on the object Hall's paraffin wax. Once it fell on the paraffin wax, it released another type of particles. That other type of particles were protons. One fall in the fire, it is released another type of particles. What when through the beryllium target were uncharged had a similar mass to protons called neutrons. That is the now characteristic of fundamental particles. Characteristic of fundamental particles. Atom is built up a number of subatomic particles. 3 subatomic particles of greater importance understanding structure of atom: electron, proton, neutron. These are the atomic particles. The atomic particles, electron, proton and neutron, the properties are given here. See the picture, see the table everybody. Proton, positive charge, P plus, charge is plus 1, mass O1 AMU, atomic mass units. Location, proton is in the nucleus. Function, attract the electron. What is the function of proton? Attract the electron. Okay, next one, neutron. Neutron, that is N, charge low, mass 1 atomic mass unit. Location is in the nucleus. Function, buffer P plus to P plus. The repulsion to help stabilize the nucleus. Electron, E minus, minus 1 charge, mass 1 by 2000, otherwise 1 by 1837. The book is given like this, 1837. That atomic mass that is a mass 9.1 multiplied 10 power minus 28. So that function is participate in chemical reaction. Proton and neutrons are actually called nucleons because they are located in the nucleus. AMU means what? Atomic mass unit. It is defined as 1 by 12 of atomic mass of carbon 12. Carbon 12. Okay, isotope. So there are two structural part of atom: nucleus, empty space, which are imaginary path is called orbit. So structure of atom: inside the neutron is there, outside electron is there. Okay, yes, shells are there. Proton and neutron are present in the nucleus. Proton and neutron present in the nucleus. So that is called nucleons. Protons and nucleons are called Protons and neutrons are called nucleons that are found in nucleus of atom. Orbit. What is orbit? Orbit is define the path by the electron revolve around the nucleus. Orbit is a path that is electron revolving around the nucleus. That is orbit. Okay. Next one, we atomic mass, atomic number and mass number. What is atomic number? Already we studied atomic number, mass number. What is atomic number? Atomic number is the number of protons. What is atomic number? Number of protons. Number of protons, that is the atomic number. In nucleus of atom and determine the identify of each element. The mass. What is the mass number? Number of protons and neutron. Number of proton and neutron is mass number. Total number of protons and neutrons are called mass number. Atomic number means only proton, number of proton. Okay, have you understood? We will see some examples. Okay, mass number is equal to number of proton plus number of neutron. Okay, for example, see the picture: helium, number of proton is 2, number of proton and neutron is 4. So atomic number is 2, mass number is 4. Okay. Next one example I will give. That means is in the book. Nitrogen atomic number is 7, mass number is 14. Mass number is 14. Now you do in your home what is the carbon atomic number and mass number, oxygen atomic number and mass number, silicon atomic number and mass number, beryllium atomic number and mass number. You write it in your home. Okay. After one example, magnesium. Magnesium atomic number is 12, mass number is 24. So what is the number of neutron? Atomic number, you know, atomic number 24. The proton number, you know, that is 12 minus 24 minus 12 is equal to 12. So the number of neutron is 12. Number of neutron is 12. One problem sum given here. Problem 1. Calculate the atomic number of element whose mass number is 39 and the number of neutron is 20. So we can find easily. Yes, 39 minus 20 is equal to 19. That is the atomic number. Yes. So element having atomic number 19 is potassium. Potassium. Understood everybody? Yes. Calculate the number of neutron in the following atoms. See the test yourself. That also do in your book. Okay. Aluminium 1327. What is the atomic number? What is the mass number? to write it. Okay. Yes. Next we have to see mass. This sorry, atomic number. One more example given here. Carbon 6, mass number 12. Another carbon 6, mass number 13. It is a isotope. It is a isotope. So examples of isotope. It is one example of isotope. And mass number. Atomic number means number of proton. Mass number means number of proton and number of atom. Number of proton and neutron. Okay, this is a mass number. Have you understood? Electronic configuration of atom. Electronic configuration of atom. Yes, already we said K cell, L cell, M cell, N cell. First cell is a K cell. Second one is a L. Third one is M. Fourth one is N. So first shell only 2 electrons are there. Why? First cell N is equal to 1. N is equal to 1. That is the number 1. So every capacity 2. 2 multiply 1, 2. See the table, everybody. 1, 2. That is 2 electrons. Number 2 L cell. That is 2, number 2. So that capacity also 2. 2 2s are 4. 4 2s are 8. So L shall have 8 electrons. M shell that is a 3. 2 multiply 3 square. 3 square that is 9. 9 2s are 8. 9 2s are 18 electrons. N shell that is 4. That a capacity 2. 4 4s are 18. 18 2s are 32. 4 4s are 16. 16 2s are 32 electrons. So K shell 2 electron, L shell 8 electron, M shell 18 electron, N shell 32 electron. Have you understood, children? First cell 2, second cell 8, next cell 18 electrons. So outermost cannot have more than 8 electrons, and the shell just next to it have more than 18 electrons. More than 18 electrons. New cell is formed as soon as in the cell attain 8 electrons. An atom becomes stable when its outer shell has 8 electrons or it has only one cell containing 2 electrons. Okay? Have you understood, children? K, L, M, N cells. Okay? This distribution of electrons revolving around the nucleus of atom in different orbits is called electronic configuration. What is electronic configuration? Distribution of electrons revolving around the nucleus of an atom in different orbits is called electronic configuration. Electronic configuration. Okay. What is electronic configuration? Understood, children? Geogrammetric representation. Also atomic structure. See the picture. It is a magnesium element, magnesium, that have 12 atomic number, 24 mass number. So first K shell 2 electrons are there. Next L cell 8 electrons are there. Next 2 plus 8 10 electrons have been accommodated. The next 2 electrons go to the next cell. Have you understood, children? Totally 12. First shell 2, next cell 8. So total 10. 2 is extra. The 2 extra one going to another one. M shell. That is M shell. K L M shell. Okay. M shell have 2 only electron. 2 only. Okay. Yes, this is a geometric representation of atomic structure. Geometric representation of atomic structure. Okay. In the book also, another one given, oxygen. Example, oxygen given 8. 8 is the atomic number. 16 is the mass number. 8 is the atomic number. 6 is the mass number. Atomic number of number neutron is equal to 16 minus 8 is equal to 8. Number of proton 8, number of electron 8, number of neutron 8. Electronic configuration 2. First K shell 2 and next N cell only 6 electrons are there. Okay children, have you understood? Two examples given. Okay. This lesson after I will teach. You study this one. Okay, write your homework. 10 one-word answers. 10 one-word answer you write it. Okay, read the lesson properly and write the answer. The box also given importance also there. Do you know? Yes, that like some tables given there. Okay, that also you study and write it in your homework. Okay, write any 10 one-word answers. Okay, classwork problem 1 and problem 2. Page number 128, problem 1, page number 29, problem 2. That two very small, simple only, very simple only. That one write it in your classwork note. Write it in your classwork note. After you study this, what is the electronic configuration, that value of electronic configuration, that also you study that example atom of oxygen, atom of magnesium, that like some properties of neutrons, that also I gave here. To study properly this one. Okay, atomic number, mass number, everyone you study it. Okay, okay children, write it properly, write the homework properly, send quick. That same day you send your homework. Okay, yes, yes, everybody prepare properly, write neatly. Okay children, thank you.